All right, let's take a look at this example. 42x to the 10th minus 28x to the 7th minus 56x to the 5th. Let's see if we can identify the greatest common factor. Start breaking this guy down. 7? All right. So you guys agree that 7 goes into all of these guys. How much x are you going to take out of everybody? 5. And take out x to the 5th. So if I divide or factor out the 7x to the 5th, what do I have now?
6x.
I have 6x to the 5th. Then what? It's 4x squared. Okay. Because negative 28 divided by positive 7 is negative 4. You had 7 factors of x, but you factored out 5 of those, leaving you with just 2. And then what do I have at the end? I have minus 8 at the end. Do y'all agree? Mm-hmm. Now, this is like a lot of the relationships that you guys may be in, where this is good, but it's not great. It's not perfect. It works for right now, but maybe it's not the end-all, be-all. Because see, even though this answer is not wrong, it's just not right enough. Okay? You've been there. Okay? Now, why is this not right enough? No, look what you have inside here. These guys all have a common factor of what? 2. So even though 7 goes in there, there's some stuff that we were missing, which is that common factor of 2. So if I look at just the stuff here on the inside, I see there's a common factor of 2. If I factor out the 2, what's left?
3x.
3x to the 5th, and then what? Minus 2x squared.
Minus 4.
Minus 4. Now notice that when I took out the 7x to the 5th earlier, this was multiplication here. Now that I'm taking out the 2, this is still multiplication. So if I took out a 7 and I took out a 2, that means that my GCF was supposed to have been what? 14x to the 5th, right? Now, even though we didn't see that, that's not necessarily a bad thing, right? Maybe you need to look at it piece by piece so you can see that 2 times 7x to the 5th is 14x to the 5th. That's my true GCF. And then what I have left is the 3x to the 5th minus 2x squared minus 4. How do I know that this is the right answer? Well, I can't go any further with this, and I should also be able to multiply it back out to get my original. 14 times 3 is 42, x to the 8th. Excuse me, x to the 10th. Man, that's negative 28, x to the 7th. And then finally, you have negative 56x to the 5th. So everything checks back out. Questions about that? Okay, let's keep going with these, see if we can identify the GCF in each of these examples. Now this always seems to be a tough question. So let's see what you guys can do with this. X to the 21st, y to the 35th, plus x to the 17th, y to the 44th. Okay. How many terms do I have? I have 2 terms, right? These guys are stuck together as one term. These guys are stuck together as my second term. That means if I'm pulling out a common factor, how many terms do you think I'm going to have on the inside? Shouldn't I still have 2 terms? Look up here. I had 3 terms. After I factored out the greatest common factor, I still had 3 terms on the inside, so that I could distribute to get back the original problem. Now here, what do you think is the greatest common factor? What do these guys have in common?
X 17.
They both have 17 factors of x.
And y 35.
And they both have 35 factors of y. Do y'all agree? Now I want to make sure we do this piece by piece. Okay. If I look at just this guy right here. If I take out all of these factors of x and factors of y, what's left?
X to the fourth.
Just x to the fourth. Do y'all agree?
Mm-hmm.
Okay. So plus, what's left from the other guy? I don't have any x's, but I just have y to the ninth, right? Does that look okay? Yes, question.
So the reason why you start out with x to the 17th and y to the 30th is because those are the smallest.
Right, and what you're going to
numbers.
find out is that the smallest exponents are the ones that will limit you, and that's the most that you can take out. Okay, just like if you were to go out with a group of friends and you can't go wherever you want to go. Okay, you go to the place where the person with the least amount of money can still go, because you don't want to exclude them, right?
So when you go to factor, you're basically going to add back in.
Right, so if I multiply this back, I will have two terms because I'm distributing across the addition. And if I look here, I'm going to have 21 factors of x and 35 factors of y, so that's the first guy. When I do this other part, I have 17 factors of x, then I've got 35 and 9, so that's 44 factors of y. Do y'all agree with that? All right. Let's keep on going. All right. How about 15, a to the 7th, b to the 4th, minus 25, a to the 5th, b to the 5th, plus 30, a to the 4th, b to the 9th. Now you have a lot of different pieces to consider. You have the coefficients to look at, but you also have the variable components in each term to see if there's something in common. If I focus on just the coefficients, the 15, the 25, and the 30, what number goes into all of those? 5 goes into all of those. Okay. In terms of the variables, is there something that they all contain? They all contain factors of a. What's the most that you could take out? The most I could take out of everybody is 4. What about your b? Just 4 factors of that guy. You may say, why only 4 factors of a? Why not 5? Because this guy has 5. Although he does have 5 factors of a, you couldn't take 5 out of this guy. He doesn't have enough. Okay. So if I factor that out, tell me what I have from this first term.
3a to the third.
Just 3a to the 3rd? Do I have any b's left here? No. I had b to the 4th, but I took out all of the factors of b. All right. Now look at this next term.
-5.
-5 what?
81. Just 8.
A to the first. How much b?
1.
B to the first, but I don't need to say, I don't need to write the 1, do I?
No.
Okay.
The 60.
All right, this last guy right here, you have 30 divided by 5 is positive 6. How much a?
5. 0.
I don't have any factors of a, but I do have 5 factors of b. Do these guys have anything else in common inside here for all 3 terms? No. Although these first 2 guys both have a, this last guy doesn't. So if there was more stuff to take out, every piece would have to have that in common. Okay. How could you check your work again? Just multiply everything back. Now let's look at negative 3x squared minus 6x plus 30. What's the common factor here?
-3. No. Yeah.
Now, notice how this polynomial is set up in descending order, the highest degree down to the constant term. That's how we want our polynomials set up, and it's going to be super important for us in this chapter when we're trying to factor, to have things set up in descending order. Now, you can say that 3 goes into all of these guys, which is great, but it's better to say -3 like you said, Mariah. Because if I take the negative out, that means on the inside I'll lead off with a positive coefficient, and that's going to really help me out later this week, and even today. So if we take out a factor of -3, what about x's? No, not everybody has an x. So take out the -3 from -3x squared, what do you have?
Square.
Plus,
It's a positive x squared.
well, I'm sorry, I was -6, you said
And that-
plus 2x.
Right, so now it's a plus because -6 divided by -3 is positive 2x, and then what?
Minus 10.
Positive 30 divided by that factor of -3 is -10. And just a few moments of your time will see that this is correct. That's -3x squared, -6x, that gives you a positive 30. So take the moment to check to make sure that everything does get back to the original. Are there questions about that one?